Now that we've had some practice computing probabilities with the standard normal distribution, we can look at applying the standard normal distribution to different means and different standard deviations. And the idea here is that given a different mean and standard deviation, we can compute the corresponding z-score, and that'll translate it into a value that we can compute using the standard normal distribution. Okay, so if I'm given a distribution that's normally distributed but has a different mean and standard deviation than what we've been dealing with before, then we can always convert that value to a z-score that we can use with the standard normal distribution. Okay, so this converts values, and in this case a particular x value that maybe has a different mean and standard deviation than 0 and 1. So this converts values to the standard normal distribution. So to round z-scores, we'll generally stick to 2 decimal places. So let's try out an example. Consider your height in inches. Calculate the standardized z-score for your height, given that in the United States, the average height for women is 63.7 inches with a standard deviation of 2.7 inches, and for men is 69.1 inches with a standard deviation of 2.9 inches. Would you be considered tall for your gender? Okay, well, I'll do my height, which my height is, from what I remember, about 71 inches. So let's compute the z-score for this particular height. So we know that our z-score will be x minus the standard, or sorry, minus the mean, and then divided by the standard deviation. In this case, the height I'm given is 71 minus the mean, which for men is 69.1 inches. That's the mean for men, so I'm going to use the mean for men, 69.1 inches. And a standard deviation of 2.9 for men, so that would be what we'll use for sigma. So when I calculate the z-score here, 71 minus 69.1 divided by 2.9, I get something around 0.65. And in my case, I would not necessarily be considered tall for my gender, even though my height is above average. It's not more than 2 standard deviations above the mean, in which case it's not necessarily an unusually high value, right? So it's not more than 2 standard deviations from the mean. So it's not unusual. Okay. So if I had a z-score that was more than 2, then that would be unusually tall. What is the probability that someone of your gender is taller than you? So how would we translate this to a probability problem? So we can think of, in this case, because my height was 71 inches, the probability that somebody is taller than me is the probability that their height is greater than 0.65, or I should say their z-score is greater than 0.65. So that's thinking of it now as as it relates to the normal standard, standard normal distribution. So if I were to compute it this way, I would stick to how we were doing it before, where I'm going to use the normal CDF with a lower value of 0.65, an upper value of any large number, and a 0 and a 1, since here I'm using z-score. On the other hand, if I were to use my height, which was 71, I would use x is greater than 71 to find the probability that x is greater than 71. I would now translate this differently. So we'll still use the normal CDF function. My lower value would be 71, my upper value 1e99, and now my mean would be different, right? The mean we'll use is 69.1. Standard deviation was 2.9. So this is how we were doing it before, using the standard normal distribution. But we can also compute it in this way here. Instead of using the standard normal distribution, we can just input the new mean and standard deviation, and that way we don't have to worry about computing a z-score. But really, the z-score kind of translates that height into a more standardized value that we can compare with other heights as well. So in any case, if I were to enter these values into my normal CDF, so we have a lower value of 71, upper value of 1e99. Here I'm going to make sure to put the mean of 69.1 and a standard deviation of 2.9. And that'll give me some height of around 0.256. Or sorry, probability of 0.256. There we go, okay. So on our graph here, we can imagine, right, we had 69.1 was the mean, 2.9 was the standard deviation, so 69.1 plus 2.9 would give me 72. And then another plus 2.9 to that would give me 74.9. And then another 2.9 to there to give me 3 standard deviations above would be 77.8. If I'm going on the other side, 69.1 minus 2.9 would be 66.2. And then minus 2.9 again, 63.3. And then minus one more 2.9, one more standard deviation below would be 60.4. So in my case, because my height was 71 inches, we can imagine that we were finding the area of everything to the right of 71. When we're finding the probability that x is greater than 71.